Welcome everyone. This is Rahul Deharkar from Mechanical Engineering Department, School of Technology PDPU, and we are back with power transmission devices. In today's topic, we'll be touching on gear drives, then coupling, and a small brief about clutch and brake. So moving ahead, gear drives. So basically, gear drives are compact power transmission devices that control the speed, torque, and the direction of the rotation of the driven shaft. Okay, gears are nothing but toothed discs which transmit power from one shaft to other by the meshing of the teeth with other gears. So based on the position of the shaft, which can be either parallel or intersecting, the gears can be classified as spur gear, helical gear, or double helical gear, or in case of intersecting shaft it can be bevel gears, hypoid gears, or worm gears. Okay, we will touch one by one starting from spur gear. So in spur gear you can look at the animation, the construction of the gear. So as we have talked about, it is nothing but the disc. Okay, in this disc you will see toothed gears at the end of this particular disc. The similar such toothed disc will be another here, and this two what you can say disc will be mating at a single point, and due to these tooths and the rotation of the driver gear, the rotation will be transferred to the, or the energy will be transferred to the another one. The animation is shown here. So what are the key points of spur gear? So it is one of the most commonly used gear, and the teeth are parallel to the axis. To explain that, if you look at this is the axis of the shaft. Okay, this is the axis of the shaft, and you can see if you look at the teeth, they are also parallel. So basically teeth are parallel to the axis of the shaft. They are inexpensive and efficient compared to other gears we are talking about, not compared to the belt. Obviously gears are more costlier than the belts. They can transmit higher power because of the contact in mating gears is along a line. So obviously they are much more efficient in transmitting more higher power compared to the belt or rope. However, the center to center distance between the gears and the belt drive is much shorter. Okay, one of the disadvantages, it can only be used for smaller speed because of the noise creation at the higher speeds. That is one of the drawbacks of the spur gears, and it is usually used in machine tools and automobile gearboxes. Okay, so next is helical gear. With the comparison here with the spur gears, if you look at it, the construction of the toothed disc is similar. Also the shafts are parallel. However, if you look at the angle of that the teeth makes, it is not parallel. Okay, so that is the difference between helical gear and the spur gear. So teeth are at an angle to the shaft, and they are longer too. The teeth have an helical path, and mating gears have equal helix angle and the opposite hand. Okay, so smooth silent use at higher speeds. So because of this helix angle and because of the mating which is occurring at the connection point, we see a smooth and the silent power transmission even at higher speeds. The truth strength is greater than the spur gear, therefore it can be used for larger load carrying capacities. So another advantage of this is it is expensive and is more difficult to manufacture. Okay, one another type we have is double helical gears. So if you look at it, it is also called as herringbone gear, and construction wise it is nothing but two helical gears welded together. Okay, so here you can see double helical with the two pairs with opposed gears, and herringbone gear having opposed joint in the middle. Okay, so it will have all the features of helical gears and more. So they have one right hand helix and another is left hand helix. Teeth of two rows are separated by a groove. It may or may not be true depending upon the construction. Here we have the two examples. Okay, so can run at high speeds with less noise and vibration. They are well, obviously, and unlike helical gears, these gears don't produce end thrust on the shaft, rather produce equal and opposite thrust. So to explain about that, let me just take you little back. Okay, so here this is something that is not a part of your syllabus, but I will explain. So as you can see, when the mating is occurring, Okay, if let's say that the gray gear is the driving gear and the red gear is the driven, so a particular teeth when touching the point at the at this particular shaft, what is happening is this teeth is transmitting power through to the another teeth on the driver shaft, and which will be at a right angle at this particular point tangent to this particular location. Yes, so here there is no extra thrust, it is in the that particular thrust is in the axis, is what you can say, is perpendicular to the rotation, and thus there is no additional forces generated. Whereas if you look at this particular type of gear here, since the mating is acting happening at an angle, then the power is transmitted, the resultant force is at a certain angle, right? Because of that angle, the force, the entire force is not transmitted in the rotation, it is at due to it is being at a certain angle, so a thrust force is generated in the helical gears. To overcome that, if we have this kind of arrangement where the thrust force from here is compensated by the thrust force from here, then that is how double helical gears can have is able to restrict, what we can say, rather produce equal and opposite thrust on each wheels and get balance. So that is the one of the advantage of double helical gears. Now moving on to the bevel gears, which is in which case you will see that now the shafts are not parallel, they are intersecting. So this type of gears are used at transmitting power in the shafts when they are not parallel. So yes, like you can see it used for power transmission between intersecting shafts. Teeth are in the form of conical surfaces. Differentials in automobiles, the differential that you see, the big, if you had ever looked at a truck, you can see a very big kind of a chunk at the rear wheels, you see a very big kind of a dome. In that one you see it, in that one usually there are bevel gears for the power transmission. Okay, so here we can have two different types, and those types are shown in the images also. First is the teeth are radial and for low speed, or spiral bevel gear, where you can see that teeth are spiral. The reason for the radial and spiral is similar to the spur and helical gears teeth, to have smooth operations and to transmit higher power. Okay, so this is one example animation to show how the bevel gear works. Okay, so we red color if it is the driving one, then the power will be transmitted to the green one, which is at a intersecting shaft. So similarly we have worm gear. This is a very typical arrangement for a worm gear. You can see, so in worm gear usually is used a large speed reduction are needed. So as you can talked about here, you can in the animation also you can see the rotation speed of this particular gear is much higher compared to the this particular gear, which is rotating at a very high, very low speed. So when there is a require of reduction in speed, the reduction ratio is too high, then worm gear is usually used. So but worm gear has a sliding contact which is quite tends to produce heat and have relatively low transmission efficiency. So as you can see here, when the worm gears have the sliding contact here, unlike the previous gear we had here, the sliding contact is maintained with multiple of the tools, which tends to produce heat and is obviously having a relatively low efficiency. This is the example of one example of the worm gear. You can see this is usually used, if you had used any of the robotic cars or something, that if you just open it up, there you will find something like this, because the motor that you have that is used in the small RC vehicles, they are not powerful enough to run that particular device, but they are have a very high RPM. So that high RPM is converted into high torque with the help of this worm gear, and that is used. Okay, so consist of the worm or the worm wheel, this is called as worm or the worm wheel, and worm has helical threads, and worm wheel has a tooth profile of a small segment of a helix to engage with the worm. Okay, so shaft axes are at right angles and are non-coplanar. High velocity ratios can be obtained and used in lathe, milling machine, drilling, etc. So the example that I gave you was something that you can find it at your home, but in industries it is used in lathe, milling machine and drilling machineries. So another is rack and pinion. Here you can see it may not look like a typical gear, but if you observe this is one of the arrangement which is used for in your driving wheel. Okay, so in driving wheel, the rotation of the, what we can say, the wheels is what we can say done with the help of this kind of arrangements. Let's look into it. So in rack and spur gear, basically the rack is nothing but a spur gear with infinite radius. Now what is the rack? Rack is this down portion part. Okay, so what they are telling is spur gear of infinite radius. So just assume a spur gear, this is a spur gear, right? So just assume a spur gear having infinite radius. So a spur gear with infinite radius will look something like this, right? A linear one. So this is nothing but rack. So rack has straight treat, converts rotatory motion to linear motion. Here you can see rotary motion of this particular red driving gear is shifted to the linear motion. Okay, so it is used in automobile steering mechanisms. So now let's move on to the coupling part. So to explain the coupling, I have an animation here. So basically, like I talked about, there has to be a connection between the driver and the driven. So here just assume that the blue colored one is the driver and driven is this, the green colored one. So we can have a direct coupling between them, but if there is a change or the change in the position of the driver, then we need certain form of coupling in between these two. Yes, so in this small part we'll be talking about what are the different type of coupling that can be done. So first we have rigid flange coupling. So rigid flange coupling is nothing but bolting of the two what you can say shaft together with one another. Here you can see shaft 1 and this is shaft 2. They are just bolted with the help of a flange to one another. So what is the design feature? Designed to draw two shafts together tightly so that no relative motion occurs between them. Yes, as easy as that. And it is used when precise alignment of the two shafts is required. So here there is no travel between the shaft 1 and shaft 2. Okay, so load path is from driving shaft to its flange through bolts into the mating flange and into the driven shaft. So basically what they are in this line suggesting is, let's assume that this shaft is the driver one and this shaft is the driven. So load from the shaft 1 is passing through this flange, then through these bolts, and then back to shaft 2. That is the transmission of the power. That is how the transmission of the power. So basically here I can ask you one question: where will this particular flange fail, or where is the highest load in this particular flange? Obviously your answer should be the bolts. Okay, so that is where the power is getting transmitted, right? So moving ahead, the advantage of this is high torque transmission capacity, easy to assemble and disassemble, and simple design and easy to manufacture. Whereas the disadvantages are cannot tolerate misalignments due to there being no what we can say arrangements for the having a little bit of misalignment. The bolts are directly connecting the two shafts. It cannot tolerate misalignment. Cannot be used where the motion is free from shocks and vibration. Can be used only when, right? So because this line is suggesting is, if there are multiple shocks and vibration, this load, the impact loading on the bolts, will cause the bolt to break and thus the failure of the rigid flange, and require more space than the muff coupling. So we'll talk about the muff coupling later, but that's it. So moving ahead, we have the flexible bushed one. So here you can see there is a difference between normal ones and this one. The rigid flange coupling and this. So I will talk with the help of this particular diagram. So let's just see if this is our main shaft which is rotating. Okay, so how will the power transmit? From this shaft it will go to the flange and then to the bolt, right? But after the bolt you can here see there is one more connection. What is that? That is nothing but a rubber bush, right? So rubber bush is little bit compressible. So this a little bit compressible compared to the bolt, and then from the rubber bush the power is transmitted back through the flange to the shaft 2. So because of this rubber bush and its inherent property of being little bit flexible, little bit of misalignment is possible in the fixed bush coupling. Let's look at its key point. So rubber bushing or over bolt pins provide flexibility and can accommodate some parallel misalignment. So that is one of the advantages when compared to the previous coupling that we had seen. Advantages are, it can bear 0.5 millimeter of lateral or axial misalignment, can prevent shock and vibrations, it can be used for transmission of high torque, not very easy to assemble, and disassemble, right? A little bit of complexity is involved, but we get multiple advantages out of it. So this advantage is obviously it will be costly and requires more radial space. Now moving ahead, you can see this is one animation of the coupling. Okay, this is a very simplistic structure. Okay, you can see how the two shafts are coupled with one another. So with the help of this principle, there is one coupling which is called as a universal hooks joint. So here I will show this particular hooks joint can accommodate misalignment for more than 3 degrees and angular misalignment up to 45 degrees. So the misalignment here is very big. Okay, consists of two forks and a center bearing block, and the two pin passes through the block at the right angles. Now to explain how it is, so this is the block. Okay, so in this block you can see there are pins, okay, at right angles, and these are the forks. In this fork, if this fork will be connected to this side, whereas these forks will be connected at the top, okay, with the help of these pins. This is how it would look like connected. So when it is rotating, this can allow the misalignment of around 45 degree. Okay, if the animation is here the same animation as before, this part that you are seeing, okay, this part is your universal joint. Here you can see when it is going at an at a certain height, you can see the angle, this angle of up to 45 degree can be achieved. These are the forks and this is the pin blocks. Okay, so those was the different types of coupling. Now moving ahead to the clutches. So clutches basically is nothing but it is a device to engage and disengage driven shaft from driving shaft during the motion to change gears meshing without stopping the driving shaft. So basically speaking, it allows a temporary disengagement from driver to driven shafts. Okay, temporary disengagements, and this temporary disengagement can be used for changing the gears and such. Okay, so the operation is based with the help of friction, and classification can be single plate clutch, multi-plate clutch, conical and centrifugal clutch. Let's look at it one by one. So here in the animation you can see what is happening. So just look at it and I will explain it once. Okay, so what we have, this is a driver shaft which is continuously rotating, and this is the driven one. Okay, so and this is just a very what we can say is a simple animation to show the explanation. The material that you can see here is shown with a different color. It is to show that the friction is taking place, and this is one disc. So what happens is when we want the driven to be rotated, spring arrangement is causing the was causing this plate to be sticking to the driver part, and due to the friction this entire shaft will be connected and it will start rotating. And when we want to disengage, due to the help of the lever, this particular plate will be pushed backwards. Okay, so let's look at it once again. Now it is not rotating. When we are letting it go, it is rotating, and when we don't want, we push it and it is stopping. Okay, this is a very simplest arrangement for clutch. Obviously in real life we have a little bit complicated and construction. Let's look at it. This is a single plate clutch, and the idea is similar to the animation that you saw. So this a part that you are looking here, this particular portion, okay, this is the driver input shaft which is continuously rotating. Okay, and this is the output shaft. So here also we will have a spring and we will have a pressure plate. Okay, and this will be a clutch plate, and this will be the output shaft. So similar to the previous one, when it is when the clutch is not pushed, this particular pressure plates will be exerting force on the clutch plate, and this all will be connected with the help of friction with one another. And because of that, when the input shaft is rotating, the output shaft will also be rotating. But when the clutch is engaged, what will happen is force will be exerted in this direction, causing opposite to the direction of the force by the spring, causing the pressure plates to move backwards and thus disengaging with this clutch plate. Okay, so that is how a single clutch plate works. It is exactly same as here. This was your clutch plate, this was the spring, this was your force applied on it. What we had seen, there is a bigger casing on top of it. That is what in construction we can see, a big casing over the entire scenario. Okay, this is one way The another versions is just multiple plate disc clutch. So here, as you can see, because it is based on friction, there is always a chances of slippage, and to overcome that, multiple plates can be used. So multiple plates also will have the same structure. It will have friction rings, it will have friction linings, it will have spring, it will have driven shaft or driven shaft, disc and flywheels. So same construction there, but only thing is multiple what you can say friction disc will be there, and multiple what you can say connections will be possible when the clutch is engaged or disengaged. Obviously this was more costlier than the single one, but efficiency of this one would be much higher, right? Now sometimes what we can say, when the normal force is required higher, then cone clutch are used. In this one you can see that rather than having a straight friction disc, we have the conical friction disc. Okay, thus allowing a higher area. The construction is same. This is the driver one, this is the friction disc, but rather than a single plate, we have a conical structure. Okay, so that is the difference between cone and a multi-plate or single plate. Okay, this is the advantage of this, is we get a higher normal forces. Now disc clutches, if we look at the summary, less heating and limited power in disc clutches. It can handle shock, it can handle acceleration, use a spring force to connect, and can be multi-disc. Okay, and the different types, if you look at it, there is centrifugal clutch also. In this case what we have is works on the principle of centrifugal force. As driving shaft rotates at high speeds, the shoe move rapidly outwards. The outer surface of the shoe are covered with the friction material which engages pulley. Thus the pulley rotates rotates with the driving shaft. Now here what they are telling is this is the shoe and the spring. So in between you can see this is the friction material. When the rotation occurs with the help of centrifugal force, these are pushed upwards, causing the top part also to be connected with one another, and connecting the both of the driver and the driven, and starting the motion. Okay, this is just to show few examples of centrifugal clutch. We have shaft, we have shoe, and the centripetal force will cause it to this shoe to be connected to the shaft. Okay, now going to the brakes. In brakes we have two different types, which is drum brakes, is similar to the clutch that we had seen, or we have the disc brakes. Okay, so let's look at it. In usually brakes is also friction. Here these are used to stop the motion, and here you are seeing a simple structure of a disc brake. In disc brake you have this disc which is noted by number 8. We have 0.7 which is the pads, and the rest of the thing is the hydraulic connection that we see. When you push the paddle, what is happening is you are forcing the hydraulic liquids from the piston towards the what we can say the pads. These pads then closen up on the disc, then causing it to stop. I have few videos to show here, with the help of which we can be able to understand this. But before that, let's look at what are the features. Frictional resistance to shock move wheels. It is obviously used in automobiles, lift and hoist. Convert kinetic energy into heat energy. Difference, the typical types of brakes are block shoe, band and brake, band and block, and internal expanding shoe brake. Okay, so let's look at few of the video to get the idea of how the brake works.
Brakes are usually used as rear brakes in automobiles. Let's go through the parts involved in the system, and see how it works in detail. Brake drum acts as the braking surface on the wheel side. Wheel hub, the part to which the brake drum and the wheel are attached to. Let's have a closer look with the wheel hub off. Backplate, this holds all the brake components together. Brake shoes. These will be pushed against the inner surface of the drum. The friction between the lining and the drum is what makes the wheels to slow down. Hold down spring holds the brake shoes towards the backplate. Retaining springs returns the brake shoes to its resting position. Wheel cylinder, the hydraulic part which pushes the brake shoes. Modern drum brake systems are self-adjusting, which means when the lining wears out, the system adjusts the brake shoes towards the drum. For that, the system uses a brake adjuster, adjuster lever, adjuster spring. The wheel cylinder receives the force that we applied on the brake pedal. At the back of the wheel cylinder, there is an inlet port to receive the fluid, and a bleeder valve to remove air in the system. Let's have a look at the exploded view. The cylinder body, dust boot, pistons, piston cups, piston cup expanders, return spring. When force is applied on brake, hydraulic fluid pushes the wheel cylinder pistons, which pushes the brake shoes. This action creates friction between the brake liner and the inner surface of the drum, and brings the automobile to rest.
Well, that was a very simple explanation for drum brakes. Here is the explanation for the disc brakes.
Are usually used as rear brakes in automobiles. Let's go through the parts involved in the system, and see how it works in detail. Brake drum. Let's see the exploded view of a car wheel, and the parts involved. The wheel hub assembly, the disc brake rotor, the brake caliper assembly, the wheel, and the lug nuts. The wheel hub assembly holds the wheel and the disc rotor, and the bearing inside it allows their smooth rotation. The disc rotor is the part to which the brake pads squeeze against. This will create friction that retards the rotation of the wheel. The disc rotor produces a lot of heat due to this friction, and the drilled holes provides ventilation to remove this heat. The brake caliper assembly uses the hydraulic force from the brake pedal to squeeze the brake pads to the rotor surfaces, thus creating friction, and decelerates the wheel. The caliper assembly consists of the caliper bracket, slider pins, dust boots, inner brake pad, outer brake pad, caliper frame, and inside it, the piston. The caliper frame is having a banjo fitting, through which the fluid will reach till the piston. The pressurized fluid from the pedal's side is capable of pushing the piston with great force. Also, the caliper frame is free to slide along the slider pins within the fixed extend. Now we know the parts, let's see how it works. When you apply the brake, the caliper will receive the high-pressure hydraulic fluid from the brake master cylinder. The fluid will push the piston, which makes the inner brake pad to squeeze against the disc rotor surface. As a result, the fluid's backward force will push the caliper frame along the slide pin, which makes the outer brake pad to squeeze against the other side of the disc rotor. Let's see one more time from the top view. The fluid pushes the piston, and the piston pushes the inner brake pad. Once the inner brake pad is pushed against the rotor, the fluid will push the caliper frame. The outer brake pad will now be pulled towards the other side of the disc rotor. This is how the disc brake system works.
Okay, so that was the brief discussion about how drum brake and disc brakes are, and that's all for this particular topic. The video that you had seen, the link is here, and the animation, the link is here. For any further discussion, you can directly contact your faculties, and that's all for this particular topic. Thank you.